Materials supplied by Microsoft Corporation may be used for internal review, analysis, or research only. Any editing, reproduction, publication, rebroadcast, public showing, internet, or public display is forbidden and may violate copyright law.
So next, let me invite Professor Huayi Wu to come to stage. Professor Wu is a professor and a director assistant of the State Key Lab of Information Engineering in Surveying, Mapping, and Remote Sensing at the Wuhan University. And he's going to give a talk on Geospatial Service Web, sharing geospatial information rather than data. So, Professor Wu.
Thank you. Hi, thank Dr. Zhao. The title of this session is about smart sensors and city OS. So, from my understanding, city OS is a kind of operation system for smart cities. And the smart city is a very hot topic right now in China. So in a traditional operation system, managing data and sharing data is a very important part. But in the smart city, data is not the only information that we should manage and should be shared. So my topic is we should share more than data. I will start from two use cases and then propose the concept of geospatial service web, and then I will demonstrate a prototype of geospatial service web and give brief conclusions. So my lab is surveying, mapping, and remote sensing. So all the information are geospatial. I'm not quite or have a very clear concept of smart city, but from our understanding, smart city should have huge information about a city, including 3D models, underground structures, and indoor geospatial information. So from geospatial domain, we think we need big data for an efficient decision-making environment for smart city. So the data can be citywide or neighborhood or individual or in national global context, and at all temporal scales, from annually, monthly, daily, and real time. So the smart city is a kind of next step of digital city. We think smart city has three characters. The first is smart city should manage real-time data streaming from all kinds of smart sensors. The second, applications based on widely shared and information resources. So we have so many, so big data, every persons, units, or governmental sectors, they share the data for a smarter decision. The third is a feedback loop from response to monitoring and data acquisition should be formed for this kind of evolution. So this is architecture we think about smart city, and there are four kernel technologies, from cellular perception through sensors to ubiquitous connection and high performance computing or cloud computing for decision making, and also for after computing, there is intelligent services. So in this use case, we need to share a lot of computing resources, but from geospatial domain, we think we need to share online and interoperability of information resources, including 3 levels. The first is data, from static data to dynamic data stream acquired from real-time sensor web. The second is information for awareness of all normal or abnormal situations in a city. And the third level is knowledge for integrated decision making. So currently, the cloud computing is a very, very suitable or promising computing infrastructure for geospatial domain in smart city operation or research. This is the first use case I introduced. The second use case is geospatial information science. Traditionally, geospatial information science research is based on local machine. We collect data by ourselves. We use the data, develop algorithms by ourselves, and we develop some model. But at this moment, geospatial data becomes bigger and bigger. So we encounter a lot of problems of processing data and get information and create a model. So in geospatial information science, we encounter a lot of challenges, including data sources, data processing. For example, for data processing, can we use commercial software or we use open source? We use existing algorithm or own developed algorithm. How to compare with other existing algorithms, and where we can find some other people's implementation. And we also need an analytic model. And for this model, we need a lot of expert knowledge. But when we are graduate students or we are doing research, sometimes to create such kind of model is not so easy. So challenges become especially very critical in geospatial domain. This challenge comes from the features of heterogeneity in geospatial domain. For example, we have various data formats, different coordinate systems, different kind of data models, and a lot of rich semantics. So interoperability becomes very, very important in geoinformation science, doing research or for teaching. So these 3 questions arises from our daily research. The first is it possible to share data directly and online instead of downloading, transformation, or manually transfer? The second, is it possible to share processing algorithms directly and online to get processing results? And the results is usually kind of information. And the third is it possible to integrate distributed processing algorithm directly and online to form a geoscience model So model is a kind of knowledge, and shares this model and the resource of this model. So in geospatial science, actually we have did a lot of efforts. For example, OGC has published the web service framework for service chain to create a model, to execute model. And in geospatial domain, we have also a lot of standards or specifications for sharing geospatial data. And this has become even applications. For example, MapWorld or USGS one-stop data service system, they have published their data through data service specifications. And like these companies or organizations, they also provide services of geoprocessing algorithms. But the problem is here, for the first question, in geospatial domain, it is now easy to share data directly and online, but to share processing algorithms directly and online, almost major, but still not widely applied. For the third question, to directly and online share geoscience model is still not a major yet, and mainly on research stage. So what we do is try to, in the third question, can we have an environment or a visual tool to share directly and online models for all researchers or students, so they can stay on the same line to share their knowledges. So we propose a concept called GeoSurface Web to umbrella such kind of activities or architecture. So we proposed this concept in some of our papers. And what is geospatial surface web? It is kind of web to connect all kind of resources, including data, processing algorithms, and knowledge, as well as those people who use this data, information, and knowledge. Yeah, and furthermore, geospatial surface web extends the data from static data to dynamic real-time data. Extend to the service from algorithm itself to a visualization form so that everyone can easily use the services. Here is the architecture of the web we propose. So in the registry center, we should have a mechanism to register sensor resources, data resources, processing resources, information resources, and knowledge resources. So users can, through this architecture, this system, to share his resources and to use the resources. So based on this idea, we developed a prototype called GeoSquare to demonstrate GeoSurface Web to share beyond and more than data, including algorithms, geoprocessing models, and sensor data. Yeah, here is a few more minutes. Here is the interface to share the data, to use the shared data. Here is interface, visual interface to create a model, and you can directly execute a model on our platform. And directly visualize the result through the platform of GeoSquare. And we have deployed this system on Windows Azure, and Windows Azure give us sufficient support to make the system run smoothly. We also have a video, but for time limited, you can access our website for more information about our prototype. Brief conclusion. Many applications need a share of geo information, but not only data, also algorithms and models. And cloud computing can support this kind of system. Okay, here's the end of.